So today, I want to talk about functional programming. And before we go too far, for anybody who does not know about functional programming, but has maybe looked into it and been intimidated, this talk is for you. For anybody who is very familiar with functional programming and is ready to judge me for my correctness, get ready to judge. It's going to be awesome. So before we do that, let's talk a little bit about me. Sorry, that's a picture before I shaved. So this is what I look like now. And I've been doing this for a while. I started in about 2003. I got my start on MySpace, as I think most people in my generation did, building custom headers and super sweet little Flash animations. I'm really big on process and efficiency, which is one of the reasons that I got into functional programming, and it's one of the things that I do at IBM. It's, kind of why they brought me in. I'm also very big on work-life balance. That's a whole different talk that I do, but the short version is that once upon a time, I worked so hard that I got stressed out enough that my beard actually fell out of my head. I changed things, and my beard is back. I got better. I'm currently working as a developer at IBM. I've written a few books on nerdy shit, and I'm really, really good at bear hugs. I do a lot of bear jokes, I'm sorry. So before we get too far into this, let's talk a little bit about what I'm not here to do. Because there's a lot going on in this talk, and it can be taken a number of ways. So let's start with what I'm not doing. The first thing is, I am not here to convert you. I don't want to make you into a functional programming believer or a functional programming purist. I'm also not trying to convince you to convert all of your code to be written a certain way. I don't think that that's a healthy way to approach programming. I think that one of the greatest things about JavaScript as a language, and a lot of the more flexible languages, is that we can do anything with them. And if we take advantage of that responsibly, then we can get a lot of really, really good things out of it. So you should use the good parts. I personally believe that the best way to get stuck in life in general, but also especially in tech, is to become very dogmatic about the things we believe. If I'm only willing to do something my way because it's my way, or because it's the way that I was taught and everybody else therefore must be wrong, I'm not going to get very far. And in web, that's a great way to end up becoming a legacy developer, and that's not a fun space to be in. So let's talk about what I am here to do. I am here to try to share some of the things that I've learned through my experience in building web applications to make your life a little bit easier. So I'm hoping that through this talk, you're going to learn a few techniques that are going to improve your code quality in a lot of situations. But again, this is not a silver bullet, so it's not going to fix all of your problems. Cool? Cool. Okay. So what is functional programming? So functional programming is kind of an interesting thing. Who here has tried functional programming or looked into it a little bit? Okay, of all those hands, keep them up if you kept doing it. Okay, so a handful of hands came up. Okay, so you guys are going to be super pissed at me by the end of this talk. So what does this mean? This was one of my very first intros to functional programming. Was looking at the documentation. This is from Ramda.js, and I love Ramda. I use it all the time, but I'm going to pick on them really hard for a minute. This makes no sense to me at all. I have no idea what it is. And if you do know what this means, this would be a great time to fake an urgent phone call, because it all goes downhill from here. So then you start digging into the examples, and they don't get a whole lot better. So we're looking here at the lens, which what we were just looking at, this is called the signature of the lens function. Now, I'm going to be totally honest, I still don't know what this means. But it's something about what goes in and what comes out, and those letters, I assume, stand for strings or arrays or something. So it's not super clear. But then you get to the examples. And the examples, rather than showing you how it works, introduce, I think, 6 additional functions that you need to look up before you can understand how lens works. So it's really, really opaque. And it gets worse, because the jargon in functional programming is horrendous. When I first started looking into it, I thought, okay, this looks useful. I could try this. And I asked somebody, hey, what should I do to learn functional programming? And they told me, go study category theory, and then come back and start looking at code examples. And I was like, I'm not going to do that. So you just start seeing all of this ridiculous jargon, and it just goes and goes and goes for days, and finally, you're like, you know, I get it, I give up. I don't want to do this at all. So I love this GIF, by the way. I could watch this all day. It gets overwhelming, though. You just kind of start to feel like, okay, this is that stuff for the really advanced, like math majors, PhDs, people who are not me. Because I'm not. I'm a college dropout. I have no education in computer science. Everything I've learned, I mostly learned from W3 schools. So I have like no formal training whatsoever. So when I start looking at, you know, monads or category theory, I go blank, right? But I don't actually think that's what functional programming is, and that's why this space pisses me off so much. Because I feel like functional programming is this incredibly powerful tool that isn't that hard to get into if you can avoid the jargon. So let's try this again with the jargon-free version. And I'm kind of lying about that, because I'm going to introduce some jargon, but I'm going to explain it. So functional programming is code that is designed to help make our code easier to understand and debug. It makes it cheaper and easier to maintain. I'll talk a little bit about why. It's more legible once you get your head around the style of functional programming. It's more reusable, more on that. More testable, which is probably my favorite part of it. And it's less error prone. And we can do that by following 3 fairly simple rules. So the first one is, we want to try to use functions instead of loops whenever possible. And I know that sounds a little crazy. It sounded crazy to me when I first started looking at it, but it makes more sense as you look at the structure. You also want to try to always return the same result if you have the same input to the function. And if you're rolling your eyes at me right now, I promise there are reasons. And you want to write functions that do one thing, no more big mega functions. So let's look at each of these steps kind of in depth and look at how. So the first thing, functions in most cases are better than loops. And let's look at an actual example. So if you're looking here, this is a list of beverages. And if you notice, there's a problem because vodka made the list of beverages. And I realize as I'm saying this that I'm in Scandinavia and like clear alcohol is totally a thing here. So I'm sorry, everybody. But we want to use a program to fix this beverage list. So a little bit of jargon before we get started. There are 2 ways that we could solve this problem. There's imperative programming. And imperative programming is probably what we are most likely to encounter in the real world. And imperative programming is an idea of your program explicitly describes how something is done. I'm going to make some American pop culture references. I hope they translate. So this is a movie called When Harry Met Sally, and the way that she orders food is extremely imperative. It's very, very detailed. I like it heated, but I don't want the ice cream, and I want it on the side, but strawberry instead of vanilla. It's very, very, very detailed, and there are a lot of places for it to break. And it's also extremely easy to get this wrong, and it's hard for the people reading it to follow. So another way to approach this is what's called declarative programming. And this is one of the concepts that kind of sits underneath functional programming, which is the idea of describing the result rather than the steps to achieve that result. This would be a way of ordering declaratively. Doesn't matter, doesn't care if they're sunny side up or scrambled, doesn't care if they're hard-boiled, he just wants them all. So does that make sense? Everybody with me? So let's take a look at some code and actually fix that beverage list. So the first way we're going to do it is we're going to look at doing it imperatively. And so you can see here, what we're doing is we're setting up a for loop, then we're setting up an if, and inside of that if, we're setting up another for loop, and then inside of that, we're setting up another if. And ultimately, what we're trying to do is decide, for each person, if the person has beverages, loop through the beverages, see if that beverage is vodka, and if it's vodka, fix it. That's a lot, and it's something that we lovingly refer to as the pyramid of doom. The pyramid of doom is that idea of just infinitely nesting everything. And you can imagine in more complicated data objects, this pyramid gets deep, and it gets really, really hard to debug. Because what happens if that structure changes somewhere between the first and 7th loop, right? Do you have to rewrite everything in the middle? Maybe, probably. So this is not a particularly maintainable way of approaching this problem. So let's take a look at a declarative solution. So declarative code is going to, instead of setting up loops, we're going to write a function called fixBeverage. FixBeverage accepts a string and replaces the word vodka with whiskey. Okay? Then we're going to write a function called help if confused. And what that does is it takes a person, and it returns the person, but it replaces the beverages with a fixed beverage if that exists, right? And then finally, we map the help if confused to all the people. So instead of setting up multiple loops, we set up a two steps, same as the imperative solution. It's 2 steps. Get all of our people, check for beverages, get all the beverages, and fix it, right? We're doing the same thing. At the bottom, we take all of our people, we map a function to it, and then inside of that, inside of each person, we map a function to the beverages. Same solution, significantly easier to maintain. Because if something changes and that beverages item ends up being nested 2 or 3 levels deeper, we don't have to rewrite a pyramid of doom to make that change. We just have to rewrite that beverage function, and we've solved the problem. So the result that comes out is identical. We get the list back, and vodka is fixed. So for anybody who's not familiar with it, I use something called mapping. Mapping is an extremely powerful way to apply a function to every element in an array, or a list, or however you want to, an iterable. What that means is something like this, where we have a function called double, which will take any number, multiply it by 2, a list of numbers, and we want to double each one of those. What we would have to do imperatively is, or I don't even know if you'd call this, without using map, is you would set up an empty array, you would loop through each of the numbers, and you would run the multiplication to get your doubled list. If you do that using map, you don't actually have to do that. You write the function, you get your list of numbers, and you just map that function. It's much cleaner. It's a little, and once you get your head around the terminology, what mapping is, it's a lot easier to understand than a bunch of loops and fors and things like that. So something that I would really recommend for everybody, try to get familiar and comfortable with the different array methods. And I'm going to list several of them at random. There are a lot more than this. Filter is very good for getting, if you've got a list of numbers, you can apply a condition, and if that condition is true, it keeps it in the list. Super useful. Sorting, if you want to get them in alphabetical order, or if you want to apply a sorting function, you can do however you want to do that. Every means that if everything in the list is true, then it matches. Or if everything in the list matches, then it comes back true, or all sorts of good stuff. And there are many more of these. So, everybody with me so far? All right, I see some nodding heads. Rule number 2: we want to always get the same input given the same, or the same output given the same input. And if you're looking at that thinking, well, of course, that's what code does. If you execute code, it's always the same. And that should be the goal, right? If we start our program, it should be predictable. But there are a lot of edge cases where that's not true. So let's do a little bit more jargon. Let's talk about pure functions versus impure functions. Who has heard that term before? See a lot of hands. Awesome. Okay, so let's look at another scenario. We're going to tell people about our favorite thing. And I bet you can guess, my favorite thing is whiskey. So we have a function, and this would be an impure function. We set a global variable called whiskey. Then we build a function called describe my favorite thing, which grabs that global variable and returns a sentence describing my favorite thing. Okay, so far, so good. Then we get a feature request. Okay, great. So let's clarify. I don't like any whiskey. I like aged whiskey. Okay, so good. That's a good thing. I want that. However, this then starts going through QA, legal gets involved, and we decide, okay, whiskey's not a good thing. This is a family-friendly app. So they change what my favorite thing is, and they change it globally to scented bubble bath. Okay? And the problem is, if we've got a sufficiently complex app, we might end up with code that looks like this, where we set whiskey up at the top, functions are happening, and down at the bottom, it says that I like to drink bubble bath. That is not what I intended when I wrote this program. And it's really difficult to debug this, because again, you don't know where these things are being handled. These functions are black boxes. Black box functions are almost always a bad idea. So instead, let's look at how we can make these functions pure, get the same thing. So if we take this, and instead of making it a global variable, let's just accept that variable as the argument. So really nothing changed, except you have to explicitly pass what you're sending to that beverage, or to that function, as an argument. So when you put in whiskey as the beverage, it'll say, I prefer to drink quality whiskey. If I put in orange juice, it will say the same thing, only orange juice instead of whiskey. Very predictable. If we want to clarify, we have to pass in the thing that we're clarifying. And when we make it family friendly, that's always going to return scented bubble baths. Notice that it's returning and not setting a global variable. And that makes it significantly easier to debug. So if we are describing, and I left off, no I didn't. So we have, our favorite thing is declared as whiskey, and we can do it as a const because we're not going to modify it. We then clarify it using clarify favorite thing, and we also get a new favorite using make family friendly. And when we call these functions, we can see what was passed into each one of these. So we're calling it with my favorite thing, so we can look up in the code to the declaration and see immediately, okay, that makes sense, that's what we wanted. And then when it gets weird, describe my favorite thing, we know that we should probably look at what new favorite is because something's not right. Okay, so our debugging just got significantly easier. And another bonus of doing it this way, when you have functions that always return the same output for the same input, you get something that's called referential transparency. And this is a big word that basically means same in, same out. And what makes this so powerful is that we can replace the function call anywhere in our code with the result of that function call. And for testing, this is huge. Because it means we don't have to test our entire app. If you're testing a series of functional calls, you can test each one as a unit test and know that if that unit test pass, anything that calls that function before it runs itself is also going to pass because there's no way that it couldn't if that function is pure. So that means that we're looking at something where if I say, you know, I love clarify favorite thing cheddar, I love aged cheddar, those two declarations are the same because of the referential transparency of clarify favorite thing. Clarify favorite thing with cheddar as an argument will always result in aged cheddar the way that we wrote that function. And this is really, really, really good for testing because we can literally test that. And we know that that's true, and if it's not true, it means that somebody broke our function, or we broke our function, more likely. Added bonus. This allows us to do something called composition. Composition is the idea of plugging together multiple functions to make super functions. And a really useful, we'll look at some more useful cases of composition here in a second, but what we can do is take this describe my favorite thing function and the clarify favorite thing function, and we can compose them together. So a little bit of weirdness with compose. It might look like it's going to run from top to bottom. It actually runs from bottom to top. Because if you were to put those on a single line, the function on the right gets called, and that result gets passed to the function to the left of it, to the left of it, to the left of it, until you get a result. There's a way in Ramda, if you want, you can use pipe, which will reverse that order if it's more logical for you to go top down. For me, with the functions, it made more sense to think about it as like each one calling the next. But what this does is when you compose, we pass in the functions as arguments. Notice that we're not calling them. And what that gives us is a super function that when we pass in whiskey, it will clarify whiskey, so it changes it from whiskey to aged whiskey, and then it passes that result, aged whiskey, to describe my favorite thing. So our result is, I prefer to drink quality aged whiskey. This is extremely powerful because each of those functions is individually unit testable, and when we start reusing these later in our code, it'll make our code base a lot smaller because maybe just clarify favorite thing could instead be clarify whiskey, and we have another one that would be, I don't know, clarify juice, and we would change out instead of aged, it would be fresh squeezed, right? So any of those things could be done, but we wouldn't have to rewrite the I prefer to drink quality blank. That function continues to be useful. So Composition, like I said, is the same as calling it like this. Describe my favorite thing with clarify favorite thing as the argument and whiskey being passed to it. It's just a little bit easier to read. The benefit being you don't have to drop the data in up front. So rather than having to build a gross loop that would call each result, you can build this function once and then map it to an entire list to get all of your results. Okay? So let's do, each function does one thing. We have a scenario here where we have a list of, we've got 4 albums. I was too lazy to make it small enough to read. So just trust me that there's 4. And what we want to do is filter by genre. So there's hip hop, rock, and indie on this list. And we want to filter down by genre and then sort by the artist. Now, if you can notice that when you're sorting, this isn't like a typical sort where you would just be able to do A to Z, because we have to get into the artist field and then sort by that. This is another really good use of the array methods. So if we do this as an all-in-one solution, like a monolith function, so to speak, you would end up getting the albums. You build an empty array to hold the filtered albums. You have to loop through them, run an if statement. If it matches, then you would do the filtered. Push, then you would have to also do the sort, and that takes another function, which is going to then give you the ordered albums. And the way that sort works is a little confusing. I have to look it up every time I use it. You basically compare the two things and provide 1 or -1 as to whether or not they should go up or down, or 0 if they're the same. Just look it up. Like, you're never going to memorize it. But if you do it as one function per step, this gets a little simpler. If you create a function called byArtistAscending, you just have to define your filtering function, okay? And then I have another function called getOnlyIndie that checks for the indie genre, and then I can run them just chained. Basically, we could do this with Ramdas functions that would allow us to compose them, but since the array prototype lets us just chain them together, we don't need to bring in a library for that. So now we've got, we start by taking our albums, we filter to just the indie, and then once we've got our list of indie, we sort it by artist ascending. But this gets more powerful, because we can actually make this even more useful. What if we wanted to allow our users to sort by genre kind of arbitrarily? Well, we can take our initial filtering function and run something called curry, that I'll talk about in just a second, and then we can build our different filtering functions just by calling filter by genre with the genre that we want. And then hip hop is albums, filter only hip hop, right? Super useful. But what's that curry thing? And it's not this curry, it's this curry. Currying is named after Haskell Curry, who was one of the mathematicians who helped popularize the concept. And what it means is that you can call the functions in stages. So imagine that instead of having to give all 6 arguments, you could call that function 6 times, each time adding another argument to the front of the list. So let's look at an example of how that works. If we wanted to add 2 numbers together, we've got add numbers 1 and 2, and it will return numbers 1 and 2. If you tried to call it without currying it with add numbers and the number 2, it would fail. It would give you an error. But if you curry it, then we can call it with add number 2, and it'll give us another function. And that function then accepts the second argument, but it's already got another number. It's got the number 4 in it. So we're able to take a really generic function and make a more specific function out of it using currying. This is extremely useful. I mean, this is a pretty trivial example, but as you start looking into, like, let's say that I've got a list of tags that I want to filter against, and so I need to send in a user object and a tags object. I could curry a function with the tags object already in it. So then I just have to pass in the user object, so it makes it easier to map against an array of users. Does that make sense? I see a couple people. Anybody still awake? Okay. So let's take a minute. Let's recap. I think we got sufficiently nerdy. So functional programming is something that is going to allow us to write code, and this is just a straight copy-paste, so I'll go fast. It's easier to understand and debug. It's cheaper and easier to maintain. It's more legible. It's more reusable, more testable, less error-prone. And all we have to do to get all of those benefits, remember that functions are typically going to be better than loops. Always return the same result given the same arguments, no global variables, no side effect. I'm not going to talk about side effects. Basically, accept an argument, only use things that were passed as an argument, always return a predictable result given those arguments. And make your functions small. Write functions that do a single thing. Now, this is just the very, very tip of the iceberg with functional programming. And if you go deeper, you're going to start to see things like monads, like category theory, and that stuff can be super useful, but you don't need it. You don't need to be a PhD to start using functional programming today. You can get all the benefits without learning a single mathematical term. So I hope that, that you guys will do that. That's what I just said. And that's all I got. So thank you very much.